cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
Most of the universe is invisible. We can't see it, touch it, or detect it directly. Yet, it shapes everything. This is the enduring mystery of dark matter. When you look up at the night sky, at all the twinkling stars and distant galaxies, you're only seeing a tiny fraction of what's truly out there. Imagine the universe as a vast, cosmic ocean. The stars, planets, and galaxies we can see are like tiny, glowing specks of plankton floating on the surface. But beneath that shimmering surface lies a deep, invisible current that dominates everything. Astronomers first noticed something was off when they studied how galaxies move. They spin and cluster in ways that just don't make sense if you only account for the matter we can see, the stars, gas, and dust. The gravity from all that visible stuff simply isn't strong enough to hold them together. It's like watching a merry-go-round spinning so fast that everyone should fly off, but somehow they don't. This led to a groundbreaking realization. There must be something else out there, something unseen, yet incredibly powerful, providing the extra gravitational pull needed to keep galaxies from flying apart. They called this mysterious substance dark matter. It's the invisible scaffolding of the cosmos, the silent force that dictates the structure and fate of the universe itself. We can't see it, but we can see its effects everywhere we look. It's a cosmic ghost, and scientists have been chasing it for nearly a century, trying to understand the invisible that dominates our universe. The story of this cosmic ghost hunt begins way back in the 1930s with a brilliant and often eccentric astronomer named Fritz Zwicky. While studying a massive collection of galaxies known as the Coma Cluster, Zwicky noticed something bizarre. The galaxies within the cluster were zipping around at incredible speeds, far too fast for the cluster's visible mass to keep them gravitationally bound. Based on the light they emitted, there just wasn't enough stuff there. According to the laws of gravity, these galaxies should have been flung out into the void of space long ago. Zwicky proposed a radical idea. There must be a huge amount of unseen matter, or as he called it, dunkle materie, dark matter. This invisible mass was providing the extra gravitational glue needed to hold the entire cluster together. At the time, his idea was largely dismissed. It was too strange, too speculative for many of his peers. But decades later, another pioneering astronomer, Vera Rubin, would resurrect the concept. While studying the rotation of spiral galaxies, she found the same problem. The stars on the outer edges of galaxies were moving just as fast as the stars near the center. This defied Newtonian physics. If the visible matter was all that existed, the outer stars should have been moving much slower, like planets farther from the sun orbit more slowly than those closer in. The only explanation was a massive, invisible halo of dark matter surrounding the galaxy, providing the extra gravitational tug. Since Zwicky and Rubin's groundbreaking work, the evidence has only mounted. From the way light from distant galaxies is bent by gravity, a phenomenon called gravitational lensing, to the large-scale structure of the universe, often called the cosmic web, every observation points to the same conclusion. Dark matter is real, and it's everywhere. So if dark matter is everywhere, what exactly is it? That is the trillion-dollar question, and the honest answer is, we don't know for sure. But that hasn't stopped scientists from coming up with some fascinating theories. The leading idea is that dark matter is composed of undiscovered, exotic particles that are fundamentally different from the matter we know and interact with every day. These hypothetical particles would be dark because they do not interact with light or any other form of electromagnetic radiation. They would just drift through space, and even through us, without leaving a trace, their presence only felt through their collective gravitational pull. Two of the most popular candidates for these particles are called WIMPs and axions. WIMPs, or weakly interacting massive particles, are thought to be heavy particles that, as their name suggests, interact very weakly with normal matter. Axions, on the other hand, would be incredibly lightweight particles. The universe would be filled with a sea of them. Other, more exotic theories propose that dark matter could be made of primordial black holes, formed in the very first moments after the Big Bang. Or perhaps it's a sign that our understanding of gravity itself is incomplete. What we do know for certain is how much of it there is, and the answer is staggering. All the matter we can see and interact with, every star, planet, galaxy, and living being, makes up only about 5% of the total mass and energy of the universe. Dark matter, this invisible enigma, accounts for a whopping 27%. The rest, about 68%, is an even more mysterious force called dark energy, which is causing the expansion of the universe to accelerate. So, when we study the cosmos, we're essentially blind to 95% of what's really there. For decades, scientists have been on a relentless quest to catch a ghost. They've built some of the most sensitive and sophisticated experiments ever conceived in an attempt to directly detect a dark matter particle. Imagine trying to hear a single pin drop in the middle of a rock concert. That's the scale of the challenge. Many of these experiments are located deep underground, in old mines or beneath mountains, to shield them from the constant bombardment of cosmic rays and other radiation from space that could create false signals. These detectors are essentially giant, pristine vats filled with materials like liquid xenon or supercooled crystals. The idea is that if a WIMP happens to pass through the detector, there's a tiny, tiny chance it will bump into the nucleus of an atom, creating a minuscule flash of light or a faint vibration that the sensitive instruments can pick up. Out in space, powerful telescopes are also joining the search. Satellites like the Planck Observatory have mapped the faint afterglow of the Big Bang, the cosmic microwave background, and the patterns within it provide some of our strongest indirect evidence for dark matter. The James Webb Space Telescope is now peering into the earliest galaxies, hoping to see how dark matter shaped their formation. So far, despite all these incredible efforts, no experiment has definitively captured a dark matter particle. Not one. But these failures are not a dead end. In science, a null result is still a result. Every experiment that comes up empty helps scientists rule out certain theories and narrow down the possibilities for what dark matter could be, bringing us one step closer to finally solving this profound cosmic mystery. So, where does that leave us? We're left with a profound and humbling picture of the universe. We know that an invisible substance, dark matter, forms the gravitational backbone of reality. It doesn't emit, absorb, or reflect any light, making it completely transparent to all our telescopes. Yet without it, the universe as we know it simply could not exist. There would be no galaxies, because the primordial clouds of gas after the Big Bang would have never had enough gravity to clump together and form them. The beautiful spiral arms of the Milky Way would have unraveled and dispersed long ago. The vast cosmic web, the largest structure in the universe, would have never formed. Dark matter is the cosmic glue holding it all together. It is the invisible architect that sculpted the galaxies and dictated where they would form. It is the unseen river that guides the flow of matter across the cosmos. We live inside a massive, invisible halo of the stuff, and it flows through our bodies and our planet every second of every day, completely unnoticed. We are, in a very real sense, living in a dark universe, only able to perceive the faintest glimmers of light on its surface. One day, a signal in a deep underground lab or a strange observation from a distant telescope might finally give us the answer. We might uncover the true nature of this invisible force, and in doing so, revolutionize our understanding of physics and our place in the cosmos. Until then, the mystery of dark matter continues to be one of the most compelling and profound questions in all of science. Thank you for joining us on this journey. If you want to explore more of the mind-bending secrets of our universe, make sure to subscribe and hit that notification bell. Join us as we continue to venture into the known and the unknown.